Hello, everyone. This is Ahmed Mahmoud from DataMindAI, and this is a continuation of the series AI Ready, Business Ready, Decision Ready. And last time we started the demo on the AI readiness. So what we've done is we went through the overview of what is going to happen. So we prepared our laptop or our systems, and then we have gone to the, because the code is in GitHub, so we went to the GitHub and we have cloned this code, and then we went through the process of how it's going to work. And what I was saying was just to recap from last time, and AI readiness, what I have done is to help us understand and follow the AI readiness. I have uh, split them into four main areas. I call them pillars. One is for the AI readiness. One is the trust side to it, which is about our data quality and reliability in our data. And the second one is control, is governance and security. And the third one, we said last time, it was context, semantic metadata, and feedback. So what we've done last time is we went through this in a bit of details and to see why we have done these four areas. And what we said was we are going to have a code script for each of them. So I will go through today the first part, which is trust, data quality, reliability. And as I was saying last time, it is a folder structure which you can follow. So you can see here I have added two folders for our demo and test purposes, which is not in the GitHub. I will load them. Don't worry about that, sir. But I put them here because we are going to demo, or we are going to test our code eventually. Now, all the data is dummy, and I have provided the data in the row. Data in the row, you can see there is a customer, there is event, and there is orders. And also, there are a couple of the codes are in the notebooks side to it. So in here also for to help me demo the code I have for each of them. As you can see, I have created two versions. One is for example here, this is what you are this is what you see when you clone the data. And this is our what we are going to do today. So it is going to be about data quality and reliability. So in a nutshell, in AI readiness, what we will do is we will load first. We will load raw data, which is this raw data. It had been intentionally imperfect. There are problems within it. So we are going to see how we are going to identify those problems, to validate them, and quarantine them. So, and also what we'll do is we'll define a data contract, schema and rules, and we'll use great expectations to validate the data, and we'll have apply a quality gate and produce a clean silver data set as an output. So we'll have in the bronze side, we'll have raw data, and then the end of it will have silver data set. So what we are doing here is we are going to follow a good practice in data engineering. So our structure, our in the platform, as it were, in the platform, we'll have a medallion architecture where we'll create folders for bronze, another folder for silver, another folder for gold. So we will separate where the data set we are working in. So when we are working in the bronze, we will focus on the bronze, and when we do the data quality or cleaning, we will move the cleaned data into silver, and then the silver folder as that is. And then once we do transformation in the on the silver, we will send it to gold. And in the process also, for when the data moves from, for example, from landing to bronze to silver to gold, we'll do like validation. So like in the real world, as it were. So we are going to use for this validation this great expectation. So that's why we're going to spend a little bit of time on how to do the data quality validation using great expectation. We'll follow the modern architecture as well, as I said before, and then we will have like the quality gate, as it were. So we will quarantine. We are not going to destroy or to remove or delete bad data, because we need them. We need them to give us like some insight about the data, what is happening. And then, of course, as a good practice, you don't delete data from the source, so you need to put them somewhere. And probably you might have like you can archive them for specific time, like retention. They might have their own retention period, but you don't delete the bad data which is coming there. So for audit purpose, we'll collect all this that one, and then, as I said before, we are going to move the data into the silver. So so first is first. What is going to happen is we'll have, as you can see here, because we are going to work in Python, and then because we are going to work in, for example, move from folder to folder. For example, we are now in the notebook, as you can see here. We might move bit further than that. I mean, like the root folder where this notebook is sitting, probably this one. So we need to move up, and then we need to go, for example, into the source data here, and then probably we might use this policy Python code. So in order to move around this folder structure, we need to have a way of doing it, a way of navigating it. And as you can see, each one has its own path. For example, in here on the notebook, we'll see the root folder, and then within that root folder there is a notebook, and within that notebooks we have the Python code here. So because we're going to do that side, we need to have like a system, like a package which can help us, instead of us writing like, for example, move up, and then we put the path like forward slash, backward slash, like what's happening before. We can concatenate strings and so on, but this is error prone. They might have a problem, while it might fail if when you run it in Linux, for example, or Macintosh or Mac's operating system, or it might not be like um, work across systems. So we might have a problem within it, or when you do like our own code, like concatenating them and move that way. So there is a package which is already in Python. So that package, it had a path, like as it was. So we will import that one. And first we'll see how that package works, which help us, I mean, understand how to move around or navigate around this folder structure. And then you have another one, as you can see here, the pandas. As I said before, we have the data in the row here. For example, this customer data in CSV file. So we want like a system where in Python, like a spreadsheet like system, or a table like system where there's a column and rows. This structure will help us, for example, to sort, to group, to manipulate the data itself. So for that purpose, there is a big package in Python, which is pandas. So we will bring pandas, and we will use, because it has a data frame like a spreadsheet like structure. So, and also a different functionality within the pandas, which is going to help us manipulate the data, as it were. So we are going to bring pandas, and then we are going to also bring numpy, as you can see here. Numpy is like an array of numbers. So this also will help us, like when you add data, and then efficiency, even though you can do the same thing using a list in Python, but the problem with that one is like it is very sluggish, slow, and then if you have especially big data, it will create a lot of problem for you. And then instead of that, there is a package called NumPy which help you, like data scientists, they use it heavily because it is very efficient. And also we are going to use in this demo today. Now, first is first. What we will do is like the Python, as I said before. As I said, like the let me look back to the notebook here and see what we can do in this side. So what we'll do is like the Python import, or the path, as it were, portable file and folder path. So this one, it has a couple of functionality which we are going to explore and how to use it as well in this package. So for example, there is like, if you want to know where you are in this code, you have like current working directories, CWD, and if you of course you imported like as you can see from pathlib import path. So once you import the path here, so it has like CWD current directory to tell you where you are. And then once this is a variable, for example, and it's holding the current working directory. So when you run the current directory, it will tell you where you are. For example, when I run it, it gives me like the one you see here in front of you, the one we brought this directory from GitHub, and then we are in the notebook side to it. So that's one. And then we have also another one, like if you want, for example, to build a path, not to create folder, but of course you need to build a path and then create that path in a code. Like for example here, so we can build this is very handy way of creating a path. For example, we in the root directory, which is, we know it, we are in the root directory here, and then we want to have like a data folder, and then within that data folder we want to have like a row, and then we'll have, for example, we'll put this CSV file. So for example, if you run this one, it will create for you this long path. But when you run it, as you can see here, the row is, as you can see here, there is data, row, student pass, as had been created here. But we haven't, don't forget, we haven't created the folder yet. So if you say, for example, there is another one, another very useful one. If you say exist in the folder structure, it will tell you false. It doesn't. We haven't created for example, this structure. And therefore, in order for us to create the folder, for example, here, we are in the root directory and we say the path is going to have data, and then we want to curate it. And then we can say make dir, make directory, that's it. So if you do that one, you can make the directory and you create the directory here. And then if you say which is it exists, it will tell you true, because we have created that directory using that function. So that's a very useful way of navigating and creating directory in a very efficient way using this path or path library package. Now, for the pandas, as I said before, what we want is like it is a package again with a lot which help you to manipulate or to have like analytical insight for your data in Python. So as I said before, you want to sort the data, you want to group them, you want to update certain columns, you want to add column, you want to add rows, and so on and so forth. I mean, you want to create tables as well. So it has a different functionality, these pandas, and one of them is like you have the data frame, which is a spreadsheet-like structure with the rows and columns. And for example, if you want to create like spreadsheet, for example, here we brought the pandas PD is the way I mean, it's customary. People used to, when they import like when they import pandas, they name it like PD or any name, for example. But PD is like the usual name. And therefore, what you can do is like you will look within the dot structure. What you can say is like PD dot data frame, and we create like a data frame here. As you can see, the column name is student ID. It's a string, of course, because it's column name. And then we need to put some kind of data inside it, because an ID is an integer. For example, here I can say the ID with numbers. And then you have a program with another column with a string. And then we put like a string data set here. And then the score is another column with a string. And then we put the data. And then when you run what you have created, which is df here, it will give you a spreadsheet-like structure, as you can see here. So all the one you put here, it is placed handily, like in a table, student ID, programs, score, and so on. And you have also index for it. So, of course, it's very important to know Python or Pandas or all the one we are working in. When they do like the row or their indexes start from 0, so you need to be always careful about that. So you start from 0, 1, 2, 3, 4, 5, and so on. So if you have like 10 rows, it will start from 0 and ends in 9. That's very important to notice here. And now they have this. Now we have different functionality we can use, which comes from pandas. For example, we can see the head, we can see the tail, we can see, like, for example, we want to see if you have millions of records, we want to see like the first part, the last part. We just investigate what the data look like using head and then tail. And then we can also have info about the data. You will get like many data, metadata within your tables. For example, the range of indexes, how many columns you have, and then what is the name of them, whether null count, and then what's the data type. There's integer, object, and integer, and so on and so forth. So you'll have like metadata if you put like df.info. The NumPy is like, again another one, which, as I said before, it's an array. You can have, you can see like, you can make like a mean out of it. We can put a random number from it. You can create random numbers and so on. It's very useful. We'll come, when you find it, we'll go through it a little bit details. But the key part here is like NumPy is efficient way and puts data into an array, as you can see here. And then the sign of an array is like square brackets, as you see here. So if you see something in a square brackets, means it's an array. And also here explicitly it gives like an array for NumPy. So this is about navigation within your data and the data structure, as we said before. So for the navigation, because it's very useful for you to do and understand what is happening, I have created this mini exercise where you can play in your own. So again, it works in Visual Studio Code if you have it. If you're working in Databricks, also it works fine. And also if you have Conda, also it works fine as well. So this is like the one we were talking about. If you want to create the working directory, current working directory, and put it in a variable like data underscore dir, you put it, and then you put like data for it, like for data folder. And then for it as well, we can like concatenate another folder, which is row here for the previous data underscore dir. And then also you can concurrent another one for the previous one. So you create like a path using that one, which is very useful. And then if you see what is happening there, you can see the path by creating this one. And then if you want to create those folders, as I said before, you can say make dir function, and it will give you the one. And then the second bit is like just quickly here is like to go through the path, as I said before, up and up one. For example, if you want to go one folder up, Yeah, if you are in notebook, and then if you want to go to the root folder here to the top part, what you do is like base path, and then with this path there is this one dot dot, like when you do like cd dot dot, for example, it will take you to the top part of it. So that's similar to that one. We put path, and then when you say resolve, which is, for example, put it in screen, and therefore it will tell you you move it up from the notebook to the second level, which is this one. Now, uh, you have also, you can create, as I said before, as a good practice as a data engineer, you can create like a medallion architecture for your data, where you put the raw data someplace, and then when the curated data, another one, the clean data. So you can create like bronze, silver, gold kind of folder. You can create it here within this code, and therefore you can put the data there. So there is a couple of good practices here. For example, when you try to do it, you don't put everything in one pad, all the paths together. Like here, for example, this is a good practice. What you need to do is like one at a time, you go to the root, and then you build from that root another structure, and then another structure from that one. So that will help you, and your code will be, you can read your code easily afterwards. Now, the second area is, of course, we created these folders, as I said before, in the row. We create a row, and then once you do the data quality, we'll put our data in curated. So what we need to do next is like we need to load the data, as it were. So what we do first is like we need to read the data, and because it is CSV, we have pandas and we have this read CSV. Now, as I said before, the data row is as you can see here. For example, we created, we went one. Let me go here. We are on the notebook here, for example, and then once you go to the notebook, we went to this side, which is in here. As you can see, we went to the data side to it. So we put the data side, and then from the data to the row, as you can see. So data row is this path, this one, this path, yeah. So this is a data row. So you built like until here, which is you call it data row, and then this is where we have done the base, which is the root, and then we put data and row. So once you do that bit, so there is a customer, for example, here, which is the data row, as I said before, / and then customer.csv. So that's what you are going to read. So it will be very handy, and you call it customers, of course. And then there's another one, which is orders, for example. The same thing, data row. You are going to read it from here, and that's why you are putting those paths. And now you will see you are what you built. Now we are using it in a proper way. So again, there is a very good practice here. You will need to go through this. Once you create this, it's also a good idea to see how does your data look like. For example, you can create head for each of them and see what does the data look like. Yeah, it is very small data here, for example, but that is what it looks from this screen. So therefore, if you put head for the one we have created here, don't forget this customers it is our variable. It is reading using read underscore CSV, and then it is reading it from the folder structure here using this structure. And then we want to know what had been in this variable, what is happening in this variable, what's happening here, the orders one, and then what is happening in the events one, by putting the head here, and then if you run it, we can see what is happening exactly on those files. Now, of course, there is like some issue here. When we do it this way, now we are not checking whether the customer.csv exists. and it will have a problem here. It might give an error, and therefore it might all our code might stop from working. And therefore, before we do the reading, we need to check whether the file exists, the files which we are loading exist, and then if they exist only, we can load them. If they don't exist, then we need like an information telling us it doesn't exist and which one of them it doesn't exist. And therefore, what we are doing is like this is very small code which first this the list of our files here. We are putting the list of our files, and then of course we are using this path which we put and forward slash the name. So if it is customer, it will be the customer here. So then we say are using this the path that exists before, if it exists, yeah. So if it exists, then it is going to happen. It is going to load the data. But if it doesn't exist, then it's going to tell us it's missing raw data, and it will tell us which one is a missing one, whether this one or this one. So it will give us the list of the one which doesn't exist. So this is for loading the data. So that's what we are going to use, loading the data, and this is all like dummy data for our exercise. The area, the one we are going to do, because as I said before, the data itself is not. There has a lot of problems within the data. You can see it from here what the problems are. And therefore, what you are going to do is like we need to validate what is happening. And as I said before, we are going to use for the validation great expectation. So I'm going to go a little bit on how this great expectation is going to help us and what it is. And first is first though, and we need to install it. Install the great expectation. And if you do it like pip install, and then it will give it to you. But this is a crucial part. Once you install it, and then when you import it in Python, you need to find out what the version you are working on, because each version has a different way of different way of using the great expectation. So if you start like it doesn't port from one version to the second. So if you are using like version 0.8, for example, and then you use like a code for 1.11, then it doesn't work. It doesn't work that way. So it just fails. It fails. So we need to find out which version you are, and then you need based on that version, you need to do your codes. Yeah. So that's very important one. That's why we put here the code here. So we only import that one, those 1.11. Now, the reason why we are bringing the great expectation is, as I said before, to validate. But we need to have like a couple of things we need to understand before using it. I'm not going to go into details, but I'm going to show you how to use how to think when you use this package, because it's very useful and very powerful package. But if you don't understand how it works, then it will create a problem for you. So what I'm going to do is like shortly, like for 5-10 minutes, I'm going to show you how we are going to use this package. So first is first, which if you go to their website, the Great Expectation website. So if you go to their website, of course, first is like you need to understand the version. As I was saying before, we need to choose in which version you are working, and they have two kind of Great Expectation: the cloud and the core. We are going to use the core here because we are going to use it from our laptop. So as I said, pip install. We are doing this bit, and then if you go through this one, it will just an overview of what it looks like. How I'm going to show you a little bit here, but this is how we need to use it, as it were. This is called workflow. So this workflow is very critical. That's why we need to understand a little bit about this one, and then we can go and use and use it as well. So This is like the workflow. But what I have done is like for us to understand first, we need to look at it from an overview how we're going to use it in our Medallion architecture. So for that one, what's going to happen is we will see we have a Medallion architecture. As you can see, the Medallion architecture, we have the gold. Uh, it might be, it's not confusing. This is like to make things clear. So you have the gold structure here, the gold, the bronze structure, and then the silver, and then the gold. Yeah. So you have these three structures there. So what we are going to do is like, for example, we have the source data, and then we are going to put it into the landing or just copy whatever the data is. You don't need to go that route, but it's a good practice to have the source data in one place. We call it landing, and then you would have like the bronze. The bronze, when you load the bronze here, again, it's raw data, but you do like some kind of validation here. For example, whether the column exists, it's very basic kind of sanity check. Yeah, like for example, the column exists, and or the file exists, something like that. So that's the validation which you do on here, and then you have you will send it. This is called gate, yeah. So you use great expectation in here in this gate, yeah. So what you do is like you have the rules we are coding. For example, if you have columns, the columns you need to check, you put it in the data contract, and then you feed the great expectation that one. And then if it doesn't exist, for example, what it will do is like it will quarantine it, like it will put it in one place so that to check it, and then also it will put the evidence what happened in a log, and then the clean data, or in this case the data which we want, raw data, is going to go to the bronze here. So bronze is like we have the raw data and we don't want to change, and we need to keep history as well. So that's the one. And then we'll have, like in this case, we'll have a second gate. As you can see here, this gate is like again, we feed it like the data contract. Yeah, we can check for completeness, for missing column, missing, for example, maximum, minimum kind of thing. So we check some kind of validity of the data for the bronze to clean it up, as it were. So if there is some issues with that data, the one with the issues, we put them in the quarantine, and then we put it in the log, and then of course we have the monitoring side to it, and then the clean one, we'll put it into a silver. Again, you can go on the silver side. We do the same thing on the silver. We will go again. We'll check the data before doing like transformation. Again, we take the rules, what rules we need to apply, and then we do it in here, and then the clean one will go to gold. The one which is problematic, we put them in somewhere in quarantine, and we need to audit what is happening, and so on and so forth until we reach the end of it. And this is the last one. So we have the gold, the same thing again. We validate at each stage, yeah, the data, and the problems ones, we put them into the quarantine now. Now, the other side which we need to go through is the great expectation itself. What do you need to do? Again, you need to spend a bit of time here to understand the structure of this great expectation, or the flow, as it were. Yeah. So first, when you work with great expectation, the first part is the context here. As you can see here, the context in this side is the like the engine, the one which is going to do the work, the heavy work, as it were. So it will have you will load it, for example, in memory, whatever you are going to work, the configuration ones, and the how to manage validation. This is the engine. So you need to have it's an object-oriented programming here in place. So they have a class, and then you need to the object, or you instantiate that class to use it So you create an object, which is a context. So once you create that context, the context you need to go to a database, and also you need to give the context now where is going to look for the data. So you need to give is a database or a file. So that one is also another one. They call it data source. So you need to have the credentials. So great expectation need like the credential to go to the database and which database you are asking that one to go for. In our case, we are going to use the pandas as it were. So we are putting our data in pandas, and therefore we are going to say to the great expectation, go to the pandas data frame and work on it. So this is another one, another area. And then the third one is like the data set itself. This is again, the data set is like a table. So you go to the database or to the file. Now, within that files folder, for example, or within the database, there is a lot of tables. So you need to tell great expectation which table to use, yeah, to check for this one. So this is again another one, another data asset. And then the other side is like the fourth one, which you need to, again, is very important here as well. So you have the database and you have tables, and then some tables have like a certain structure. For example, you will have a table where you put the data from different regions, for example, and then you want to split each region. You want to check each issues with each region, for example. But in our case here, the pandas, when you give great expectation the pandas data frame, it doesn't split it into groups. It will take it as a whole. So again, you need to say this is how we are going to go. You need to check all the data frame or the table, as it were, in the panda on the one you gave it. Now, this is the critical part, the four parts. The fifth part is like, again, this is again, sanity check, as it were. So, because the way it works is like if it's a session and the data frame, once you go out of the session, you lose the data, you lose everything. So, what you need to do is like, you need to give the great expectation a, a parameter of that session, so that to work on it. So you add a parameter they call batch parameter, and say this is the data frame, is a batch file, and therefore you put that one as well. And after that, of course, the good thing about great expectation is, as I said before, it has a list of expected values for your data or for your columns, for example. So it has a list of expected values, and then you need to choose which one are you going to use. For example, in here, you have the expected expectation, they call them, or they explore a list of the expectation. For example, here, you expect column maximum to between, or it is. We can come here and see what is going to happen if you use one of them. So these are the one they called expectations. Yeah, it's a list of them, and we are going to use four out of here as well. So that's again the data frame, the expectations, and then you have the result. Yeah, the result, whether if it fails, for example, you can quarantine it, you don't delete, of course, and then the clean data you send it to. If it is from bronze, you send it to silver folder, and if you are working on the silver, you send it to gold. So that's I think that's what I thought very useful. So in a code though, what we've done is here, you create the context first, as you see here. So this is how you create the context in the code. And also this is again very important one. If you go to Great Expectation, it will show you how to do this stuff. I mean, there is a code example on each side of it. Yeah. So it's a file system, SQL, and also the setup, for example, if you want to set up here, yeah, and of course we are going to use you install it and then create a data context, and this is how you do it. You import it as great expectation, and then this is the context, and you say gx dot get context. Yeah. So, and then if you can print, you can see what's happening. So if you come here, also it will give you the code which is required, yeah, which is required for your expectation. And then also the second one is the connections, as we were saying before. So each connections have this is like, for example, you can have Databricks SQL, PostgreSQL, SQLite, and so on and so forth. So you will have the environment. This is how you create them. Yeah, the username and password, and also you can have access to vaults, and you can bring them from vault and so on and so forth. But what you need to give to once you create the expectation, you have this is the data source, yeah, the connection as it were. So once you do the context, you would go and see the data source. In our case, we are not doing SQL. You can have like add SQL, add the Databricks SQL, for example, or Snowflake, or SQLite, and so on and so forth. So you put it here, but you need to give it a name. This is a name you give it so that when you refer it later on to understand you are talking about this one. Yeah. So this is the data source, and the asset is like, as I said before, this is the table. So from the source, you are asking the great expectation to go and add data frame asset, because we are working on data frame now, and you are giving it the asset a name, the customer asset here, and also another table or its orders and so on. If you have like 10 tables, you add 10 of them here, of course. Yeah. And then once you do we say the context is very important here. This is how we need to plan them. You need to context, and then you have the data source, and then you have the asset, which are tables. And then after the asset here, we say the batch, yeah, definition. The batch here is, as I said before, for the pandas, it is only, it uses like the whole table, which is what this is all about. So it has batch definition whole data frame. So you don't have like a specific area from within the table. So all of it together. And then you have the customer batch and the order batch, which, as I said before, this is the parameter you need to add so that you don't lose your data while you're working. So you put a parameter. It's called data frame and it's called customer. Yeah. So that's how you write them. So now, so that is the great expectation, how we use them. Yeah. So as I said before, you can go through each of them, and then this is like explicit how you go one at a time. Yeah. So we've done this one in a nutshell. I'm planning probably in the future to have like specific tutorials for this great expectation, because it's very useful, especially data engineers, and now also AI engineers. They need to know it properly, because it is very useful tool, and it will save you a lot of issues in the future. Now, this is the tool itself. So we went through that tool, how it works, what we need to do there. Now the actual work here, though, as I said before, we said we need now this is where everything will be useful. It's all of them are the same. So what you do is like you need to feed the data contract to the so first you need to have what is the rules which we want to use. Yeah. So this is like business rules within the organization. Yeah. So which is like very important ones for each organization. So that is one. The feed is like this is the rules, for example, for the customer. This is we are saying the columns, which is customer ID, email, department, country, create ad. This is crucial. So we want them. So if there is a problem, if there is missing, so we need to be notified. We need to know this. We need to put it in a log or alert or something like that. So this is a required list of columns. And then we have, so for example, customer ID should be unique. So also this is our requirement. So it shouldn't be duplication of customer ID. So we want it to be unique. It's primary key as it were. And then we want like this three columns. We don't want them to have a null value. So this is rules for customer. And for the order contract, so for the order table, which is transaction, we have order ID, customer ID, amount, currency, and also and so forth. These are the required columns, required ones. So the unique, which is a primary key, should be order ID. And also we don't want nulls for order ID, customer ID, amount, and order totals. So the range also, we want like the amount shouldn't be like negative. Yeah. So it should be negative, it should be positive, always the amount column. So we can put all together, yeah, as you can see here, the contract together, the customer, which has customer contract and the order contract, and we can list them here, as you can see, as a contract, yeah. Now that is the contract now, yeah. So what we are going to do now, yeah, we are going to do the validation. So before we do the work, so we want to create like an array to collect our data before the result. So that is, we say the result should be in an array, and we are going to build the result on this array here, on this array. Yeah. So that's one very important one. So for the customer one, for example, this is the array, the starting point, and then we need to append. What are you going to append? We are going to do the batch here, and then we are going to say validate. So what you are doing here, this is the expectation. Now, we need also, when we import the great expectation, there is two imports. One is the expectation itself, and the second one is the one is called expectation. From great expectation, you import expectation. The expectation, as I said before, this is the list of, these are the expectation, they call them. This is the list, yeah? So this is expectation. So we need to bring that one, import it in our system. And once we bring it in our system, we need to do, we are validating here. This is the expectation, expect table column to match order list, which means this is the one. You have order list, which we created before, which is the contract. So we want to match it, and then we want to match it to this one, the required columns. Yeah. So the column list, yeah, should be the customer contract, which is the required columns, which is from here. We have the contract here, and also here the required. See, this is here the required columns. So the required columns are this list, yeah. So it's going to validate. So if there is nothing there, then it will have an issue. The second one is, again, we append, yeah, the result, and we see in this case as well, we append the unique, the primary key as well, yeah. So another expectation is column value to be unique. This is one expectation, and we are feeding the customer ID here, and the also the orders ID, the created at as well should be unique, as we said before. So the primary key as well. So that's another one. So not nulls, and then we have the uniqueness, which is the rules, which is not to be null. You say we have again, you need to have this one not to be null, and the unique value. So we have these two, and the unique value, to be unique is this one, and to be null is this one again, yeah. Yeah, so you can play with it. I mean, if you go here, it will tell you how to use each of them. It's not like rocket science here. You can go and you can preview it, and then you can see how to use it. Yeah. So that's from here. I brought it all. The one you see here it is from this page. So you can go each of them. You can see if it is just this is like the one we are interested, and it will tell you how to use it as well. So we have run this one, for example, and it will tell you what is happening now. This is again the critical bit. One is run. We need to summarize it. Summarize meaning we need to put it in a data frame called summary, and then what we're expecting, and then whether it was like a success or a failure as well. Yeah. So for example, we're expecting the column to match order list, and then whether it was matched, yes, it was successful. And here the expected column value to be unique, there's false here, which is a problem. And then expected column value to be not to be null, which is true here, which is good, and so on. Yeah. So that's the expected one, and this is the result. What is happening? Yeah. So so once we've done that side to it, this is very critical bit. Huh? So you can for example customer ID is failed. Yeah. You have duplicate customer ID value. This violates master data rules, and also it will have a problem with the join. Uh, so it will tell you what is happening exactly, the kind of issue we want to surface early. So this is like an example what you need to see, and then it will the not null checks pass it, which is the true one, which is required fields like customer ID and the create at are populated. Its completeness is acceptable, or ID uniqueness is passed as well. Amount to be checked failed. This is like some order amounts are negative. This violates business logic. We should have negative value. Revenue metrics would be wrong if this data was used, and therefore this is a success, not a failure of the process. So because we are identify them before happening, don't forget that we are talking from the bronze. We are going to clean or put them somewhere safe so that we can work on it, or people who know about the data can do something about it. Yeah. So there is a problem here. The schema is okay, completeness is okay, but identity quality issue and business rule violation. So we have these two area. Uh, some data is structure valid, but not business valid. So there is no problem with them. There is a value inserted there, but it's negative. So we want the business says we don't like negative values there because it's dangerous. So therefore, the structure is correct, meaning it is not a string, it is a number. So the number is negative there, though, which is violate business rules. So this is exactly why quality gate must exist before silver. The quality gate means those which was violating, we need to stop them. There must be a gate, yeah, a gate to the silver to stop this problem data from getting there. So that is what we said in the gate, as I showed you before. As I think we were talking about that here. This we put these gates in here so that we are stopping problem data. Yeah, we are quarantining them, we're auditing them as well. So and then we are sending them. So that's the gate. The idea of the gate is like to correct or business data to move to its layer, proper layer. So that is so we do not, as I said before, we don't delete bad data. We isolate it to use it. Yeah, and then now we need to do the cleaning bit. Yeah, this is a cleaning bit. Yeah. So what we need to do is, for example, standardize country code. We have, for example, United Kingdom written as UK U dot K and so on, and therefore all of them to be UK, for example. So you standardize it in one way, and therefore when people do like a reporting, it doesn't come as three distinct values, which is not true. So all of them are the same, and therefore you need to do some kind of cleaning. This is the standardization point, which we do always in the silver. For there's a couple of things which is very useful. One of them is this one in NHS data is also very very important because there's a lot of codes there, and they are written in different format because different people use different way. Some of them they put dots, some of them small letters, some of them like written there, like in United Kingdom, as you said before. Now, also, we need the duplicate data. We need to remove it. So again, we use drop duplicate, yeah, customer ID. We need to keep first duplicate when we say all of them are the same, all the row is the same, and therefore we don't want two the same data appearing in our system. So this is the uniqueness. That's why in the first place we say it should be unique, and then whenever we are talking, that's just keep the first one. So if there's 10, for example, just keep the first one. That's what drop duplicate is going to do. Now, the missing critical fields, for example, if there's something is missing, you need to replace it with something else as well. So we can bring, for example, data from if it is null, you need to put some kind of data from. You need to have a rule here, yeah, a rule to deal with a missing value, and also always, of course, the clean data, the one you have added. If it is null, for example, the null should, for example, department should not be null. You said, so what are you going to happen? So you need to have a default value for that one, default department. That's again, this should be fed from the stewards, people who knows about the data, and therefore they will tell you what need to be done. And then if there is, for example, created date, for example, if it is missing, you need to have like some kind of agreement what should be done as well. So you need to add those ones, and then there is a couple of things which I think in data wrangling there is rules which you can, some of it is average, if it's a number. You can use, like, for example, these days though people use um, like AI to populate those ones. So it's very useful one, but we need to be careful as well. We need to be careful what to put here because um, the value is missing, but if you put something, it might mess up. So the obvious one should always work here, but if it's not obvious, we need to have like some kind of agreement before just blindly putting some value here. Also, the amount, as we said before, this is business rules which you need to do, and therefore, so all the ones which are not correct, as you can see, there is a quarantine, customer quarantine, order quarantine, and we are putting them there so that we don't want to lose them. And the silver one, the one which is clean, as you can see here, we are putting them in the silver, or the silver customer silver, as it were. So you have two tables, as it were. Two, one is quarantine and one is clean, silver and quarantine. And so the now we create a working copy of the customer and the order. So we have standardized everything. We removed the one which are not good. We have, again, this is explanation of each of them, what we have done. I mean, it's, as you can see here, first of all, what we have done is like we haven't just we copy the customer, the one which we got first. Yeah. So we have this clean customer. So we are working from this one, which is very important. Yeah. A copy of the raw data. So the original one is not accidentally deleted or changed. Yeah. So we are doing the copy here, which is very important. So he say here, for example, the raw data is immutable. This is a key part here. Bronze. When you put the data in bronze, yeah, it is immutable. You shouldn't change those data here. So what we do is like, because we are moving the data into here, what we do is like, as I said before, you copy the customer copy, and then you work on the copied one. So the copied one now, this one is the country, and then you need to replace. This is a replace. For example, if it is United Kingdom, put it UK. U.K. Dot whatever, put it UK, and if it's empty, put null into it. Yeah, that's what you use, and numpy, as it were. Yeah. So fix inconsistent representation of the same country. Convert empty strings into real missing value. Yeah, missing value. So pandas treat them correctly. That's the key part here. If it is a missing value, you correct them to missing value so that they will be used. Yeah. So what happens is like aggregation and joins become reliable. So you don't get like 3 4 UK. Yeah. You will get one value for UK when you aggregate something. Yeah. So downstream models do not learn false categories. So like when you do like AI agents, agentic AI, they would not say they're different one. The UK is one and this is another one and so forth. So they would have false category. This is one standardization you have done. So this is very good exercise. Copy first, and then on the copy side, you are working on it now. Now you are going to remove duplicate, yeah, customer identity. So drop duplicate. This is the you are using. So what you are doing is like you are using the customer ID if it is duplicate, and use first if there is 2 or 10 or whatever, use take the first one. Yeah, keep first. Uh, so it is enforcing one customer ID per row, and this is just keeping the first occurrence. As it's read before. Yeah. So duplicates breaks join. Right. So if you are going to add customer and orders, if it is you have two, and then if you have orders, it might be thousands of orders, as it were. So that's a dangerous one. So duplicates is a problem when you do joins, and also when you have metrics, say, be also corrupts them, as it were. And machine learning features also have big problem if you have duplicate data. So that is the one they need to do. And then quarantine customers missing critical fields. For example, again, this is a clean, the copied one. And then what you are doing is, if it is null, and then created is null, then what you do is like copy that one and put it in quarantine. Yeah. So that's what you do, the copy environment here. So if it is null here, put them in the quarantine. Now, identify records not usable for analytics or AI because key fields are missing. So if key fields are missing, then AI is a problem. So you don't need to have a missing value. So you need to quarantine it in for example, if it's a customer, yeah. And then departments are critical one, or created data is also critical one. So we were talking about before. So if it is null, um, there is a couple of rules about there, but in here we are going to use, like, we are going to copy it in the quarantine side, and later on we are going to do some kind of work to bring it back if it's possible, or not. Just at least our data is clean. Yeah. Missing critical attributes reduces trust, breaks auditing, and time-based analysis. And now you need to create customers by removing quarantine rows. So what you do is, like, the silver one, you have the clean one, and what we are going to drop, the one which is in the quarantine. So anything which is in the quarantine side is going to be dropped, and then, or copy, yeah, drop this one, and then the clean one, copy it using the copy command, and put it in the customer silver. So silver customers that passes basic integrity check, quarantine customers that need this remediation. Yeah. So the result is a trusted data set, a transparent exception data set. Yeah. And also apply the same pattern to orders, and everything will be the same. Yeah. So order quarantine, and for the orders is the same process. Yeah. So you can see what's happening. What was the total number of customers? What was the total number of quarantine? The total number of the silver and the quarantine, and then this provide information: how many rows came in, how many made it into silver, how many were quarantine. Yeah. Now, silver data is not perfect data. It's the data that has passed the minimum rules required for trust. Yeah. With everything else quarantined for governance and remediations. Yeah. So this is a key part. Quality is not a belief; it is a measurable. So you need to measure what's the quality. This counts shows exactly what we trusted and what we isolated. Yeah. So that's so in terms of the data, we brought it from we move it from bronze to silver step. Yeah. So ensure the curated folder exists. This is in a nutshell. Um, um, so and then we need to write. Don't forget, first, we need to have, now we created the silver one, so we need to move it now. We need to move it. As I said before, we need to move from here. We need to move it into a silver created folder for the bronze. Yeah. So that is what we are going to do now. So first, though, the folder should exist. If it doesn't exist, we need to create one. We can use the code which I showed you before. So if it exists, and then if it doesn't exist, create one. And then once you do that bit, you need to write the data into the customer silver, that's what we created. We need to put it into CSV, and then this is the path which we have created or checked that it exists, and then we are putting customer silver.csv into it. Yeah, there's no index in that. So it writes clean, trusted customer data. Indexes follows, prevents pandas row numbers from polluting the data set. Uses path-based system, the one we said before. So we have written it into a silver. The quarantine one as well, the same thing for the quarantine one, as you can see here, for the order as well as for the customer. And then we need to check, we need to, of course, give information that the data has been written. And this is very important one, because it will alert what has been happening. Of course, always you need to do this it will give information what had been what you are doing here, for example. Yeah, so you put it into quarantine, and you put it into the data set, and and the information will be printed. So this is like the one you so in a nutshell, what you have done is like expect column value to be unique, expected column value to be not null, values to be between two values, minimum and maximum. And then what we've done is we are enforcing identity integrity, completeness, business logic correctness. And then we just, before the data is being trusted. And so what we do is like quality gates, the fail tests don't propagate. So if it is success, all raise, if it's not success, yeah. If there is no success, then raise value error, data quality check failed, yeah. So that's what you need to put into the logs, as it were. So you need to have, it is in quarantine and metrics, you need to monitor it continuously. And this one is, this monitoring is the key part to make your data trustworthy. So that's trust for the first pillar of AI ready, the trust side. I said it just probably is very bit long because it was by design to just to go through that one. That's the great expectation and how we validate, and then how to test it. I mean, you could have your own way of doing the thing as well. You can link the quarantine and the data to, of course, to a reporting tool like Power BI or Excel, and then it is because now it is in CSV file, and if it is in SQL as well, if you put in SQL, now it is there for you, and then you can do like a different kind of tools to see what is happening within your data. And also, as you said before, we put whatever we are doing, you need to be monitored into logs. Also, I mean, this is very crude one, just to give you like an understanding what the quality is. Like there is a couple of things which you can use. You have this automated process. You have ML Flow, for example. This is a very useful tool you can use. But again, it will hide a lot of things for you. So if you go through this process, even though it looks like a bit painful, but if you go through that process, you understand your data better, and you understand what is happening, and therefore you would have a better judgment. So that is part one, trust, or pillar number one. So everything else depends on this one, as you saw here. If data quality is bad, then whatever you do is not going to be correct. It will be amplified, as we said before, and you will get the wrong result. We are not talking about reports now, because you're going to use this AI to do for you certain things. So it could be you might automate a process using those ones. So whatever you do, if it is the data is wrong, therefore your AI agency or agentic AI will be wrong, amplified, and so on. We'll go through the data quality in a different session. But for now, this is AI Readiness. Thank you for listening. See you in the next episode, the governance and security side of it. Bye.